All right, so yesterday we talked about scatter plots and the idea of graphing two quantitative variables, which ends up being a scatter plot when we do that. So we'll look at these two examples here and use our acronym that we talked about yesterday, which is now DOFS, standing for direction, outliers, form, and then of course strength. So a little bit different than SOX, but remember, like, SOX and DOFS are essentially doing the same two things. It's just that SOX is used for graphs that are quantitative, but with one, variable, one list of data, whereas DOFS is also quantitative, but it's working with two sets of data. And then that's why we have the scatter plot, and you'll notice, we have one variable on the x-axis, one on the y-axis. So we'll go here, and we're looking at two different things here. First, scatterplot A describes or displays the time in seconds to run a 40-meter dash without shoes versus the time to run it with shoes in 82 students. So there's actually 82 data points in this left graph here, and you'll see the axes, time with shoes on the x, time without shoes on the y. One doesn't really explain the other, so there's no defined explanatory variable in my opinion, but there it is. All right, the scatter plot B displays the life expectancy in years and income per person in 179 countries in the recent year. This data collected from the website, listed there, and we want to describe the relationship shown in these two graphs. So let's start with the first one here, and we're going to just start with direction. All right, that'll be our first thing that we go for. And remember, direction is essentially saying, is it positive or negative? And in this case, if we were to sort of think about this, and we drew kind of a imaginary line, either in our head or, like I just drew one right there, we would say, yeah, this is a positive. As the time with your 40-meter dash with shoes went up, so did your 40-meter dash without shoes. In other words, if you were slower with shoes, you were probably also slower without shoes, and vice versa, right? So we would say something like, there is a positive association. And we'll just say between, and we'll put some context in here like always, the times with shoes and without shoes. Just abbreviate there for space, since we'll probably run out here in a moment. All right, so then we're going to move on to outliers for DOFs. Now, outliers, remember, outliers are points that don't fit in the overall pattern, right? I mean, we might have somebody way out here, let me put a dot that's really big so you guys can see what I'm saying, way out here that's really slow with shoes and really slow without shoes. That doesn't necessarily mean that they're technically an outlier, only because they do still fit the overall pattern. If I continued the line up, it would still fit in that range. They just happen to be someone that's just a lot slower, right? But the association is still there. They're really slow with shoes, and they're also really slow without shoes. However, if we look at this, there seem to be 2 points right here and here that are a little abnormal. They don't quite fit within that pattern. And so we would say, hey, yeah, there appear to be 2 outliers. And then, like I said, I'm going to put a dot here. Go ahead and you can pause the video or whatever you need to do. What I would do is, and the reason I'm putting dot is just because I want you to label those points. So go ahead and if you want to label those now, because we should describe them. All right, and the only reason, just to comment on that too, I didn't label them is, again, just because of spacing here. I can't shrink these things down like I can in Notability on this program. All right, so form. Form is really simple. Form is either that there is a linear relationship or there's a non-linear relationship. And really, we're going to call anything that's not linear non-linear at this point. Well, in this particular case, I mean, this looks like a pretty straight line. In fact, I drew kind of an imaginary line of best fit in there. And so we'll say there is a linear pattern here. And that's it. All right, form is one of the easiest ones to describe because you have 2 things you need to consider, linear or nonlinear. And then last is the strength. Now, we'll come up with a objective way of describing strength here in the next week or so. But for now, we're really just kind of making a decision on our own about how closely these points are to each other. Do we feel like there's a strong relationship? Do we feel like it's pretty moderate or weak? And really, those 3 words are the best 3 words, like we talked about yesterday, to use. In this particular case, just so you understand what I think, I'd say there's a pretty strong association here. I mean, it's pretty obvious that if you run slower or you take more time with shoes, you're also taking more time without shoes, right? So I'm going to go ahead and call this a pretty strong, even with those two kind of odd points out there, we'll say there is a strong association. All right, and you can, like I said, use either strong, moderate, or weak. And then we'll just say between. And then I'll abbreviate here again with shoes and without. And there you go. So yeah, as long as you get all this stuff down here, obviously if it's a test or a quiz, and like I said, if I had more space here, I would have written, the word with, without. I really don't want abbreviations necessarily on like tests and quizzes when it's formal, but, and then if you went ahead and labeled those actual outliers yourself a moment ago, this would be it. This would be exactly what you would be looking to do. All right, well, let's try this one over here. This is the income versus life expectancy. So we look at this one, and I'll be honest with you, if you were to try to draw a line kind of through this, the one that would make the most sense would be something like that. So clearly when it comes down to the form part, this is a non-linear graph. However, it does appear that the direction is still positive. I mean, as income goes up, it does seem that people are living longer, although it kind of levels out at a certain point. It looks around like $30,000 to $40,000. Everybody's got about the same life expectancy. But we'll say there's a positive association. Between life expectancy and income. Awesome. Okay, so let's talk about outliers. Outliers here. I mean, honestly, doesn't look like there's really in here. I mean, there's a few points kind of below that line, that curve of best fit or whatever you want to call it that I drew there, but really nothing seems to fit outside the overall pattern, so there appear to be no outliers. Okay. And we're going to have a more difficult time proving outliers, unlike in the last chapter where we had that rule, Q3 plus 1.5 times the IQR and Q1 minus 1.5 times the IQR, because that was really with just one set of data, and now that we have two sets of data, things are changing again. So for now, and we'll just kind of keep it as, do you think there is one or not? And it's a really kind of subjective thing. You just have to make the decision. We're not going to be able to use that outlier rule from the last chapter. In this case, we said that this is nonlinear. And then last, the strength. I mean, I don't know. Seems to be pretty strong. I mean, those points are pretty closely tied together. I can draw a pretty easy line over top of them. There is a strong association. Even though it's not linear, it's still strong. And then I'll put a ... here because, again, I'm out of room, but you want to provide some context, between life expectancy and the income. So, all right, so I'll zoom out there just so you can kind of see all of that. But that's it. That's really the last thing we need to talk about in this section. So you should have about 20 minutes here to get us start on the homework for this weekend, which is out of section 2.2, and that is on the agenda. So go ahead and get started on that now, and we'll see you on Monday, and we'll also see you at the pep rally this afternoon.